Causality and stability of the LTA system. Please tell me one thing, that what is a causal system? I think we have learned a lot in the case of the first chapter. Causality of the system. How can we say the system is causal in nature? The system is said to be causal in nature if it is depending only on the present or past, but not on the future values. But the question now is that this thing we have already learned, right? Given a relation between input and output, how to say whether a particular system is causal or not, this is something we have already learned. Now what we are going to learn here in this particular case is that given a particular impulse response, we have to comment on the causality of the system. Given the impulse response, we have to comment on the causality of the system. So a system is said to be causal. A system is said to be causal if h of t is equal to 0 for t less than 0. H of t is said to be causal when a system is said to be causal if h of t is equal to 0 for t less than 0. If this condition is satisfied, then we call the system to be a causal system. And in the case of discrete time, this is for continuous time. In the case of discrete time, h of n is equal to 0 for n less than 0. These two conditions have to be, this condition is going to be satisfied in the case of a discrete time system. Now, how did we get this particular condition? I will tell you. We already know y of n is going to be summation x of n convolved with h of n minus, x of k convolved with h of n minus k, where k is equal to minus infinity. So let us take an instant. Let my instant is n equal to 0. So y of 0 is going to be equal to, let us start with x of 0. So x of 0 into h of 0. And we know as we go down, as the value of k increases, x of 1, x of 2, x of 3. Here we have h of minus 1, h of minus 2, h of minus 3. If you go the other side, x of minus 1, x of minus 2. Here it is h of 1, h of 2, plus, and so on, right? This is nothing but the formula for convolution. Yes or no? Now I have considered the instant of y of 0. Now please tell me, for a causal system, what is not allowed? Can the system depend upon x of 1, x of 2, x of 3? In the case of a causal system, can the system depend upon x of 1, x of 2, x of 3? No, because these are future instants. Right? And the system cannot depend upon the future instants. Right? So, it should not depend upon the future instants. So, if it should not depend upon the future instants, h of minus 1, h of minus 2, h of minus 3, all these numbers should be equal to 0. Yes or no? If you want to kill the dependency on the future instant, then your values of h of minus 1, h of minus 2, h of minus 3 should be 0. This is what has been given as a condition for us. Right? So if you want a causal system, then h of n should be equal to 0 for n less than 0. H of n should be equal to 0 for n less than 0. Okay. So this is for a causal system. Next we will come to the stable system. A system is said to be stable. If integral minus infinity mod of h of t is less than infinity. This is in the case of the continuous time system. In the case of the discrete time system, the summation of mod of h of n should be less than infinity. This is in the case of a discrete time system. Okay, so let us understand how this particular criteria has come into picture. This is what we call as absolute summability. This is what we call as absolute summability. And this is what we call as absolute integrability. If you remember, when we discussed about the stable system, we have discussed that the bounded input should lead to the bounded output. The bounded input has to lead to the bounded output. Yes or no? The bounded input has to lead to the bounded output. Correct. It means that to test the stability of the system, every time we apply the input which is bounded in nature. Yes or no? It means if your output should be bounded, your input must be bounded. This is for stable system. Okay. Now we know that we always apply a bounded input. So let us take this completely out of consideration. Because we know anyway that the input is going to be bounded. So let us completely take out of the consideration. Now for the output to be bounded, the summation of the impulse response should be bounded in nature. For your output to be bounded, the summation of your impulse response should be bounded in nature. That is why we have this particular condition that the summation of all the samples of the impulse response should be less than infinity. This is what we call as the absolute summability. That if input is not bounded, is it unstable? No. How come your system stability is dependent on your input? For the system to be stable, okay, I'm sure that you didn't attend the class that we have discussed on stability, right? For the system to be stable, you have to ensure that your input has to be bounded in nature. If you want to test the stability of the system, you have to ensure that you are applying the input which is bounded in nature. Okay, that is the only criteria. So if you are not applying the bounded input, then you cannot expect the system to be stable. Applying the bounded input, you will be seeing whether the output is bounded or not. Even in one case, that if you apply bounded input, the output is unbounded, the system is said to be unstable. So can you please check h of n is equal to 2 power n into u of n minus 2. First one, stable and causal. Second one, stable and non-causal. Third one, right, so h of n is equal to 2 power n into u of n minus 2. Let us try to represent in terms of sequence how it is going to be. See, you are starting with n equal to 0. If you start with n equal to 0, 2 square n equal to 0, right? 2 power 0 into u of minus 2. 2 power 0 into u of minus 2. What is the value of u of minus 2? 0. N equal to 1. It's 2 power 1 into u of minus 1. 2 power 1 into u of minus 1. Again 0. N equal to 2. 2 power 2 into u of 0. What is u of 0? Remember, it's a discrete time signal. So u of n is equal to 1 for n greater than or equal to 0. So u of 0 is 1. So 2 power 2 is 4. N equal to 3. 2 power 3, 8. 16, 32 and so on. So 4, 8, 16, 32 and so on. If I add all these, if I add all these 4 plus 8 plus 16 plus 32 plus so on, do you think it is going to be finite? If you add all of them, this is going to touch infinity. It means that the h of n is not going to satisfy the absolute integrability. H of n is not going to satisfy absolute integrability. Right? Next thing is that whether it is causal, as you see that h of n is equal to 0 for n less than 0 is satisfied. H of n is equal to 0 for n less than 0 is satisfied. So there is no problem with causality. The only problem is with the stability. The system, as we can see that h of n is not absolutely integrable. So it is not stable. It is unstable, but it is causal. It is unstable, but it is causal. So the answer is option C. So causality, okay, I'll explain causality. See, causality is nothing but h of n is equal to 0 for n less than 0. Okay, so if you are talking about the h of n plot, this is n equal to 0. Here, h of n should be equal to 0. If this is satisfied, then we can say the system is causal in nature. And in this case, you can see, I just try to expand it. As I can see that for n less than 0, the value is going to be 0. For n less than 0, the value is going to be 0. Because it is satisfied, so we call this particular system to be a causal system. Yes. So if you have considered an advanced function like this, if you have considered h of n is equal to 2 power n into u of n plus 2, then this could have been clearly non-causal because the value is non-zero even for n less than 0. Even for n less than 0. So this particular system could have been declared as a non-causal system because once this is satisfied, then the system, the system output will be depending on the future inputs. The system output will be depending on the future inputs, which is not something which we are looking for in the case of a causal system. Okay, so there is a question about asking the step response once again. Please look into it if you are having any doubt. We are trying to find the relation between the step response and the impulse response, right? See, u of t is something that we can write as the integration of the del function, right? U of t is something that we can write it as the integration of the del function, yes or no? So, if you know del of t gives you h of t, the impulse gives you impulse response, then the integration of impulse should give you the integration of the impulse response. The integration of the impulse should give you integration of the impulse response because of the simple reason that this system is a linear system. It will support summation, additivity, and integration is also a sort of an additivity. Integration is also a sort of an additivity. So you can see that integration of del of t is u of t, integration of h of t is going to be s of t. Right. So the first homework problem on your secondary screen is x1 of t is going to be equal to mod of t. x1 of t is equal to mod of t for the value of t between -1 to 1 and it is equal to 0 otherwise. So this particular signal is discretized with a sampling period of 0.25 seconds. Discretized means if you are having a signal, any signal, you are trying to cut it. You are just trying to cut it. Sampling interval, the distance between two samples is going to be 0.25 seconds. The distance between two samples is going to be 0.25 seconds. Okay, so let us start from -1. If you start from -1, if I am talking about the sampled signal, so can you please tell me What is the value of x1 of minus 1? What is the value of x1 of minus 1? x1 of minus 1 is mod of minus 1 is going to be 1. So after minus 1 we have to take minus 0.75 because we are taking the sampling interval of 0.25 seconds. So after minus 1 you will go to minus 0.75. Mod of minus 0.75 is 0.75. Then mod of minus 0.5 is 0.5. Mod of minus 0.25 is 0.25. Mod of 0 is 0. Mod of 0.25 is 0.25. 0.5, 0.75 and 1. This is for the first signal. This is for the first signal. Second signal is x2 of t is going to be equal to 1 minus mod of t for the same region of. So again let us start. Starting from the top minus 1. Can you please tell me what is the value? Can you please tell me what is the value? When you are starting from minus 1, 1 minus mod of minus 1. 1 minus mod of minus 1 is 0. Then you have minus 0.75. Minus 0.75. 1 minus mod of 0.7 minus 0.75. 1 minus 0.75 which is 0.25. Then you have minus 0.5. It gives you 0.5. Then you have 0.25. Minus 0.25. You will be having 0.75. Then you will be having 0. 1 minus 0 will be 0. And then you will take 0.25. 1 minus 0.25 is 0.25. 0.5. 0.75. 1. I'm sorry. So 1 minus 0.25 is 0.75. 0.5, 0.25 and 0. Correction. Okay. So if you put the value of t is equal to, this is the 0, right? This is the 0. So if you put 0.25, 1 minus 0.25 is 0.75. If you put 0.5, 1 minus 0.5 is 0.5. If you put 0.75, 1 minus 0.75 is 0.25. If you put 1, 1 minus 1 is 0. Did you understand both of them? So after sampling, these are the results you are going to get. After sampling, these are the results we are going to get. Now you see which of them is having higher energy. Looking into it, which of the following has higher energy? First one or second one? See, if you observe, 0.25 is common here. 0.75 is also common here. 0.5 is also common here. Yes, so here there is a mistake. Here it is 1. Okay, at t, if you put the value of t equal to 0, 1 minus 0, it is 1. Okay, yeah, I'll repeat x2 of n once again. See, we are starting from t equal to minus 1, right? So 1 minus mod of minus 1 is 1 minus 1, which is 0. Then you go for t is equal to minus 0.75. 1 minus mod of minus 0.75 is 1 minus 0.75, which is 0.25. Then you go for t equal to minus 0.5. Okay, so it is clear. Now, if you see the difference between these two, the only difference is that here 0 comes 2 times, 1 comes once. Here 1 comes 2 times, 0 comes 1. So obviously the first one is going to have more energy when compared to the second one. Yes or no? The first one is going to have more energy when compared to the second one. So the answer is option A. Next one. Next homework problem is x of t is equal to t minus 1 into u of t minus 1, which is r of t minus 1, minus r of t minus 2, minus r of t minus 3, plus r of t minus 4. Correct? Okay, so again, we'll get back to the last problem. So there is a question that if two had different samples, then how to check the energy? Then you are forced to calculate the energy. If they are having different samples, then you are forced to calculate the energy. So R of t minus 1 minus R of t minus 2 minus R of t minus 3 plus R of t minus 4. So if you draw the graph will be something like this. The slope of 1 unit at t equal to, at t is equal to 1, you are adding a slope of 1 unit. At t equal to 2, you are subtracting the slope of 1 unit. At t equal to 3, you are again subtracting a slope of 1 unit. At t equal to 4, you are adding a slope of 1 unit. Correct? This is how the graph is. And this is what we call as the function x of t. Now you are having a constant amplitude region. You are having a constant amplitude region and a region which is something like this. A region which is something like this. Correct or not? So constant amplitude region, it is very simple to find the energy of it. The constant amplitude region, it's very simple to find the energy of it. Yes or no? Only this particular part, finding energy is very simple. Now you are having a particular triangle and you are having another triangle. Okay. So what I will do is that I will just find the energy of this particular part. This finding energy of this part is very simple. So I will just find the energy of this particular part, and it's very clear that the energy of this part and energy of this part is same. If I consider as 1, 2 and 3, the energy in the 1 and the energy in 3 is same, yes or no? Energy in 2 is very simple to find. Let us forget about this particular part. So if I am able to find energy in the 1, the total energy can be easily found. So what I will do is that I will try to shift it lightly, because I know the energy is not going to be changing by shifting. I'll just try to shift it 0, 1, 2, 3. Now you see, what is this line? This line is nothing but x of t will be equal to t for the value of t between 0 and 1. X of t is equal to t for the value of t between 0 and 1. What is the energy? Energy in the region of 0 and 1, 0 to 1, t square dt, because x of t is nothing but t between 0 and 1. So if I want the energy in this one, so I am squaring the signal 0 to 1. So it is nothing but t power 3 by 3, 0 to 1, it is 1 by 3. So the energy here is 1 by 3. Of course the energy here should also be 1 by 3. And what is the energy of this part? What is the energy of this part? Square it and find the area. 1 square is nothing but 1. 1 square is nothing but 1. So you are having the length of 1 unit, breadth of 1 unit. So it is going to be 1 plus 1 by 3 plus 1 by 3. Totally it is going to be 5 by 3. Totally it is going to be 5 by 3. So I am using that particular concept that even when I am doing the shifting, the energy is not going to change. And second thing is that energy of the constant amplitude is very simple. The energy of these two parts is same. So when I am shifting it, it's very easy to find the energy of this particular part. Once I get the energy of this part, so energy of this part and this part is same. So it is going to be 2 by 3 and the energy of this particular part is 1. So totally it is going to be equal to 5 by 3 joules. Okay, so the next question is, if you are having a something like this, a square pulse 2 minus k, minus 2 minus k minus 2, the amplitude is 1 by k. This is g of t. Right. So here we have to find the evaluation of integral minus infinity to infinity sine of 2 pi by 3 into t minus 3 divided by t square plus 2. gk of t. You see, what is gk of t? It is given that the value of k tends to 0. When the value of k tends to 0, what will happen here? When the value of k tends to 0, k tends to 0 means this more approaches towards that of minus 2. It approaches towards that of minus 2 because this is 2 minus k and this is minus 2. As k tends to 0, this approaches to minus 2 and the value of k tends to 0. So 1 by 0 tends to infinity. So is it not an impulse? K tends to 0, gk of t. Don't you think it's an impulse function? I'm sorry. The impulse at t is equal to minus 2. The impulse at t equal to minus 2. So just substitute here. If you substitute here, you know what to do, right? Del of t plus 2, put the value of t is equal to minus 2 in this one. Finding the energy in the case of the 1 by 2 power in u of n, it's very simple, right? 1 by 2 power in u of n. So summation n is equal to, generally we start from minus infinity because u of n is present, I can directly do it from 0 to infinity. 1 by 2 power n whole square, it becomes 2n, so it becomes 1 by 4 here, 1 by 4 power n. So it is 1 by 4 power 0, 1 by 4 power 1 and so on till infinity. It's a GP series of infinite terms. A, which is nothing but the first term, divided by 1 minus r. What is r? 1 by 4. So it is going to be equal to 4 by 3. Answer of the question you can calculate, right? What it will be? Minus 10 pi by 3, right? Minus comes outside. So sine of 10 pi by 3 is nothing but 3 pi plus pi by 3. So this falls into the third quadrant. So minus of minus becomes plus. So sine of pi by 3, sine pi by 3 is nothing but root 3 by 2 divided by equal to minus 2. If you substitute, it is going to be minus 2 square. It's 4, 6. Right, so root 3 gets cancelled here. Root 3 multiplied by 2. So it is 1 by 4 root 3.